This question says, assume home prices in Raleigh follow a normal distribution. Mark and Mitchell are both considering buying new homes in Raleigh. Mark's home price has a z-score of negative 0.95, while Mitchell's home price has a z-score of negative 0.15. What is the probability a home in Raleigh costs more than Mitchell's? First, draw a graph and shade the region that corresponds to this probability. First, let's draw our bell curve. This marker in the middle marks the mean. And unlike many questions, in this question we are dealing with z-score. Now the mean always has a z-score of 0. Negative z-scores are found to the left of the 0, where positive z-scores are found to the right of the 0. The further to the right you are, the more positive your z-score is, and the more to the left you are, the more negative your z-score is. Now we are being asked for the probability that a home costs more than Mitchell's. In the question, Mitchell's home price has a z-score of negative 0.15. That's fairly close to 0, and it's slightly negative, so we'll draw it slightly to the left. Now we want the home price to be more than negative 0.15, so we'll shade to the right, because the right is more. Now in previous problems we have used norm dist in order to find probabilities. Now that's if you know the x value. Now instead this time we're given z-score, not x value. So instead we'll use a variation called norm s-dist. The S stands for standard and dist stands for distribution. So anytime you have a z-score, we are going to use the standard normal distribution. Now the standard normal distribution always has a mean of 0 and a standard deviation of exactly 1. Now, norm s-dist is used differently from norm dist because it needs fewer things in the function. We only need the z-score and then a comma and then true. So we have fewer things to collect this time. We'll enter a field for z. And in doing norm s-dist, we will find the probability of being less. Remember, Excel by default does probability of being less. So we'll have to add an additional step to find the probability that it's greater. Once again, we can remind ourselves p greater is just 1 minus p less. Now let's enter what we know. The z-score for Mitchell's home is negative 0.15. To find the probability of being less than negative 0.15, we enter norm s-dist, click the z, comma, true. Now we have the probability of being less, and let's enter equals 1 subtract, and then click on the probability of being less. This gives us the probability of being greater. Our answer will be 0.559618. That's the final answer for this problem. This corresponds to the red shaded area on the graph. We can tell it should be a little bit bigger than half the graph, so this makes sense. Question B asks, what is the probability that a home costs between Mark and Mitchell's? Once again, we'll draw our bell curve. We'll mark our mean down at 0 Now our z-scores are negative 0.15, and then we also have negative 0.95 for our other z-score. That should be to the left of negative 0.15. Because it's more negative, we'll treat it as less. Then we'll find the probability of being between those two marks. So our picture looks like this. Now, once again, we can use norm SDIST for z-score. And once again, inside of that function, we'll put z, comma, true. This will give us the probability of being less. What we want, though, is the probability of being between the two marks, so then we'll subtract our higher answer minus our lower answer. Now, let's enter our z-scores. Negative 0.15 and negative 0.95. The probability of being less, we'll use norm SDIST and click on the z-score, comma, true. We'll use the black cross to calculate the norm SDIST for the other z-score automatically, and we'll find the probability of being between. We'll say equals the higher of the two answers minus the lower of the two answers. So our probability of being in between those two markers is 0.269326. This will be our answer for this problem. This question is different from the others in that it asks us to now draw a picture and shade the middle 90%. Once again, let's find our graph and draw the bell curve. Now we want the middle 90% of that area that we want to mark off. Now, the graph in and of itself is 100%. We'll need to find out how much is inside of this little left tail and this right tail. So we take the 100%, subtract 90%, which gives us 10%. That 10% will be divided equally, and it will be divided equally between the two tails. We'll take 10% divided by 2. If we do that, we'll get 5%. That tells us this first marker is 5%. And this second marker will be 90 plus 5%, giving us 95% for the second marker. Now, notice that this time we were given probabilities and asked for z-scores. Now, last time when we were given a probability, we used norm inverse, and this gave us an x value. This time we're not asked for x value, we're asked for z-score. So this is similar, but instead we'll use norm S inverse. Inside that function, we'll put the probabilities. That's all we'll need to put for this function. Once again, the S stands for standard. This is for the standard distribution that has a mean of 0 and a standard deviation of 1. Inverse we'll do anytime we know P but want to find something else. Now we'll enter our P less. Our first P less is 5%, or 0.05 if you wish. Our second is our other marker at 95%. Based on that, we can find the z-score by using our norm S inverse function. All we do is select our probability, close the parentheses, and press enter. We can use the black cross to calculate the z-score at 95% also. This tells us that at the first marker, our z-score is negative 1.64. And at the 95% marker, our z-score is positive 1.64. Notice the z-scores are almost the same, and the only difference is the sign they have. The reason for this is because the probabilities in the tails we are examining are also the same. Because the area to the left of the first marker is the same as the area to the right of the second marker, we can expect the z-scores to be identical in all but the sign.